everybody, let's go ahead and get started. I think it's like people are gonna be. I don't want to wait any longer actually to get started. We have a lot to cover. Welcome to our show webinar on CO2. How about I do this first? What I'm going to do, I'm going to centrally mute everybody's phones. And the reason I'm going to do this is because with so many people on the webinar, if a couple of you have some background noise, it can get very, very disruptive. So I'm going to mute everybody's phones by pressing *5, and should make it a little bit quieter while people are speaking. If you do need to speak after I mute everybody's phone centrally, you press *6 to unmute your personal line. So go ahead and press *5, and I'll let you know once I've done that.
You have muted your line.
I definitely need my speakers to press *6, and let me know once you've done that so I can be sure that we can all hear the speakers.
God, I've done it.
Okay. Travis and Wayne and Mark, can you *6?
This is Wayne here, Keely.
I hear you.
Travis, can you hear me, Keely?
I hear you.
Keely?
Yep, I hear you.
Alrighty.
Okay, excellent. Looks like we're good to go. Okay, and I am going to, I'll make sure everybody realizes that this webinar is being recorded, and that's so that we can make it available to those who couldn't attend today on the Green Chill website at a later time. And if you enjoy the webinar and you want to tell somebody else about it, be able to find the webinar on the Green Chill website on events and webinars. The way that we're going to handle questions, because there are quite a lot of people on the webinar, is you all have a little button down in the lower right-hand corner of your screen that has a little hand on it. If you click that on, I see a little hand appear next to your name on my list of attendees. And while everyone else is speaking, I will keep checking for questions. If you want to, go ahead and click on that little button, and Reed, Renee, Scott. Yeah, so I see lots of little hands. Jeff, Frank, Eric, yeah. So okay, so you obviously were able to find it, and then once you're done asking the question, the hand doesn't disappear on its own, so you have to then click it again to make it disappear. So we will have a 30-minute question and answer period at the end of the webinar. So if it's possible, if you have a general question, it'd be great if you could hold that question until the question and answer period. Of course, if you have some kind of a question as we're going on in terms of understanding the slides or something that can't wait, feel free to raise your hand. And don't forget, when you raise your hand, and I tell you to ask your question, you have to press *6 to unmute your phone, or obviously we're not going to be able to hear your question. So, okay, so that's it for the webinar etiquette. My name is Keely Whitman, and I run the Green Chill Partnership here at EPA. To introduce the Green Chill Partnership very, very briefly, Chill is an EPA partnership with food retailers to reduce refrigerant emissions and decrease their impact on the ozone layer and climate change. And we have three main programs. These are the three ways that we achieve that mission. The first program is the Corporate Emissions Reduction Program. These are the Green Chill partner companies that you hear about. And those companies have signed up to annual goals to reduce their refrigerant emissions. And if they meet those goals, they win awards from Greensill and they receive recognition for achieving their goals. The second program is our store certification program. And with that program, we award Greensill certification to individual stores for achieving silver, gold, or platinum emissions reduction targets. The third program is what we call the Advanced Refrigeration Program. That's where we promote the use of advanced technologies, strategies, and practices. And under that program, that's that gives us all of the Greensill best practices guidelines, the webinars, the information sharing, all that stuff happens because of the Advanced Refrigeration Program. So just very, very briefly, an overview of the Greensill partnership. Now, why is Greensill starting to have webinars about low GWP refrigerants? Well, as I said, our mission includes decreasing the supermarket industry's impact on climate change. Greensill's motto has always been, you're setting yourself up well for the future, for whatever we can foresee coming, if you follow the motto of reducing refrigerant charge, reducing refrigerant leaks, and using the lowest GWP refrigerant that meets your needs. You obviously don't want to be converting to a low GWP refrigerant and then, your efficiency decreases or your performance decreases and you're tripling your energy use. So you want to choose the lowest GWP refrigerant that meets your needs. That makes sense for the environment and for your bottom line. And if you follow that motto, not only are you should you have been well set up for the R22 phase-out that just went into effect on January 1st, 2010, but whatever comes along in the future, whether legislative or EPA regulatory action related to climate change, you know that you have done the best that you could to prepare for that, whatever comes. So that is why we are turning to some people call natural refrigerants. We call them, I refer to the category mostly as low GWP refrigerants because who knows, maybe in the future there is a chemical refrigerant that also has a very low global warming potential. And EPA's job is not to select winners or losers in the marketplace, but to make sure that there are as many alternatives as possible for all of you to make your own decisions according to your needs. So our agenda today, after my introduction here, we're going to have Travis Lumpkin speak about CO2 Cascade Refrigeration Systems. Then we're going to have Scott Martin talk about CO2 secondary coolant systems. And then we're going to hear from two Greensill partners about their experiences in the field with both of these types of systems. So we have Wayne Rosa from Food Lion and Mark Henkel from Chopper. So let's go ahead and get started. Travis, I am going to hand this over here to you. Okay, and you can go ahead and get started.
All right. Just to double check, can everybody hear me? Can you hear me, Keely?
Yeah, I can.
All right. Oh, well, thank you for everyone in this webinar. It's always a pleasure to talk about the exciting advancements we're making in our industry as well as the positive impacts it has on the environment. So today, Keely already mentioned, I'm going to be talking about CO2 and a Cascade system, and this will be a direct expansion use, our direct expansion system with CO2. And we'll get started by first looking at a simple schematic of a traditional refrigeration system. And what you see here on the screen is basic primary equipment used in a traditional market. You have a compressor over to the right, and the compressor discharges into the condenser. We liquefy the refrigerant. We have a receiver of refrigerant management. And then, of course, you see the expansion device and the evaporator coil, which are installed somewhere in the store, either in a display case or in a walk-in box. And in the supermarket, this refrigerant is circulated throughout the entire retail space, where there is expansion contraction that takes place, and among anywhere from a dozen display cases to stores that have well over 100 display cases. Now, the refrigerant charges are typically high, as well as the number of potential leak points. Let's now look at a schematic of a Cascade refrigeration system. A Cascade system is a system that consists of two independent refrigeration systems that share a common cascade heat exchanger. So if you look at the center of this, your diagram there, you'll see the cascade heat exchanger in the middle. To the left, you'll find a schematic of what we just do, a typical refrigeration system, where you have compressor, condenser, receiver. And lower right, you'll see an example of the cascade, the CO2 portion, which looks very similar to the top cycle as well. But to help give a better understanding of how the system works, I'm going to take these two portions of the system, the top part and the bottom part, separated cascade heat exchanger, and explain those each individually so you can have an understanding of how they work together. Start at the upper left-hand portion, and we refer to this as the top cycle. For applications of Cascade system with CO2, this top cycle refrigeration system, the primary refrigerant is typically used. And for the sake of this discussion, we'll assume that refrigerant is an HFC refrigerant, such as 404A or 407A or something of that nature. And as I said earlier, it does look like a typical refrigeration system with a compressor to the right, a condenser shown at the top of the screen, and a receiver again for the refrigerant management. And there's that the heat exchanger that you see after the expansion device is not represented by a merchandiser, either a unit cooler or display case. This portion of the system is here to liquefy or condense the CO2. The system is sized to heat from the CO2, which would consist of the heat loads from the display cases in the store, and walk-ins, as the heat generated from the CO2 compressors, the heat gains that are in the piping network, and such. And it's also a close-coupled system, and as you can imagine with a close-coupled system, the piping network would be significantly reduced, which would mean a lower refrigerant charge of your primary HFC refrigerant. There would be fewer joints, which would result in less leaks. There's pressure drop, which would help the efficiency of the system, as less heat gains in this portion of the system, which again would improve the overall efficiency of the system. Next, we'll look at the portion to the bottom right of the Cascade heat exchanger, and this is where the CO2 is being used as a purpose of refrigerating the retail space. To this portion of the system as the bottom cycle. Again, as we've already pointed out earlier, it looks like a typical refrigeration system. You have CO2 compressors, condenser, which is again the Cascade heat exchanger, which acts as the condenser for the CO2, receiver. But also notice on the bottom left is where the connection piping network is made to the refrigerated cases or the walk-ins inside the store. With this design, you can see that the CO2 is the working refrigerant used to remove the heat from the refrigerated loads in the store. And there are some differences that you would not see from the schematic, and that's basically in the areas of the temperatures and the component ratings that are used for use with CO2, and this what we call a subcritical application. So what we'll do next is, as we mentioned, show you the differences between CO2 pressures and what you would see on a commonly used refrigerant R404A. This slide shows the operating pressures for the CO2, and they, quick math would indicate that they are in the order of magnitude of 7 to 13 times greater than that of R404A for the corresponding temperatures that we have shown here. For the low application of CO2 that I mentioned earlier, you see pressure of CO2 at the -25 and the -15 range in the low. You would find to be the condensing pressures for R404A, which for condensing pressures you're looking at anywhere from 100 to 120 degrees Fahrenheit. That's like it's clear why we need a cascade system for the use of CO2 in our refrigeration system. You notice that the critical point for CO2, located at the bottom of the chart, is just under 90 degrees Fahrenheit, and a corresponding pressure of over 1,000 pounds. So when we use CO2 in a refrigeration system, in a subcritical system, and we use less expensive materials such as the piping and the valves, we bring the temperature of the CO2 down cold enough so that the corresponding pressures are more manageable. That's why the use of a cascade subcritical system is useful with CO2. Staying relatively new in our food retail industry, it's important to understand some of the main differences to pay close attention to when designing or selecting a CO2 for your CO2 system for your application. We'll talk about the component piping selections to determine and the appropriate materials and components are designed to operate safely within that range.
Travis, I'm sorry to interrupt. Are you guys hearing that interference in the background? Oh?
Yeah.
Yeah.
Yeah,
okay.
I can hear it.
Okay. I think what happened was I muted everybody before everybody was actually on the line. Unfortunately, what I'm going to have to do again is I'm going to mute everybody again, and then, Travis, you especially, you're going to have to hit *6 right away. I apologize for interrupting, but it got to the point where I couldn't actually hear. So I'm going to remute everyone. So everybody should be muted now. Can you everybody maybe just try to talk so that I can make sure that you're muted?
Can you hear me, Q?
I can hear Mark, yeah.
Okay.
This is Travis.
I can Travis.
This is Wayne.
Yep. So it's like, or at least since hearing anything from any of the other participants, I think everybody should be muted now. So again, I apologize, Travis. Go ahead, continue.
And during the question and answer time, if there was any area of the presentation that was missed due to the background noise, you can just ask me some questions then, and we can add that. But what I was talking earlier was on the component piping selection. With our pressures seen with use of CO2, this may mean going to something like K-type copper or valves that are rated for 600 pounds or more. Outside this, pretty common now with the introduction of R410A in the industry. Most suppliers have re-rated their components for the higher working pressures. And some of the items to pay close attention to are the proper sizing and selection of the relief and regulating valve system with CO2 as are prescribed within UL 1995. Also, the use of CO2 in a direct expansion cycle with the use of electronic expansion valves. There are currently no thermal expansion devices that we're aware of in use and approval today for a Cascade system. But the thing of the Cascade heat exchangers when you have multiple heat exchangers used in parallel. Next, we'll talk about the service. Most service valves today, or service today, have low loss fittings and such to prevent the accidental release of refrigerant into the atmosphere whenever the valves are used, or gauges are used on servicing equipment. These type of valves are not recommended for use with. Remember the chart that I showed earlier, pressures, and it remembered that 90 degrees Fahrenheit, the pressure was over 1,000 pounds. Most service applications, the emissions can be anywhere from 75 degrees in the store to well over 100 degrees outside. So if a service technician were to use a set of gauges that had low loss fittings and do service on a CO2 system, and these had the low loss fittings, once temperature of the CO2 rose up to ambient conditions, the service technician would have a set of gauges rather quickly. Another important piece of equipment to be noted for use with CO2 would be leak detection equipment that is designed for use with CO2. Next, in just a second on non-condensables. Non-condensables can hinder the performance of any refrigeration system, but it's extremely important to remove all condensables from a CO2 system, as again it will performance and as well as the operation of the CO2 system. You can accomplish this by using a high quality or grade of CO2 used to charge the system. Filtering the refrigerant as it's being charged can be done. Of course, a proper evacuation of the system prior to charging the system with CO2. Well, obviously, we'd recommend a triple evacuation, achieving a micron level of 300 microns or less. Next, on leak checking, it's important to have a leak-free system, even the CO2 side as well. A small pinhole leak in a CO2 system can grow quickly just due to the magnitude of the pressures that the CO2 is operating at. So, and robust leak check is important. And the proper training of the technicians. The Cascade system, similar to that of a standard DX system, the biggest challenge is with a good refrigeration technician being comfortable with the pressure levels, as well as being able to troubleshoot the system during operation and avoiding refrigerant trapping by use of isolation valves. The operation of a Cascade system and some of the differences relative to a system. I want to highlight some of the advantages for using CO2 and a Cascade system. CO2 is known for reducing the primary refrigerant charges, similar to other types of technologies like glycol and such. Reducing the primary refrigerant charge is a big benefit, and we anywhere from 600 to 1,800 pounds or more with the use of a CO2 Cascade system. I'm lost here just for a moment. Sounds like the phone's ringing.
The person called is unavailable right now. Please try again later.
Usted ha llamado no está disponible en este momento. Por favor, intente de nuevo más tarde.
Message 2. Switch 3 5.
All right.
You have called is unavailable right now. Please try again later.
La persona que usted ha llamado no está disponible en este momento. Por favor, intente de nuevo más tarde.
Keely, you should mute the line again.
Switch 1 3 5.
Okay, so everybody should be muted again. I apologize for that. As I'm not sure all of you were on to hear it. The Green Shield Partnership is obviously not about, our mission is not to perfect webinar technology. Mission is to reduce refrigerant emissions. We're certainly by no means experts in webinars, and they're meant to be very informal and to exchange information. And I apologize for the interruption. Tress, are you unmuted again?
Can you hear me?
Yes, I can.
All right, well, good. We're almost done. I'll wrap it up with these couple more bullet points. We'll turn it back over to you, Keely.
Okay.
Another benefit for using CO2 is reducing the primary refrigerant leak rate. Studies done by Arthur D. Little and others have shown refrigerant leak rates in the 2 to 15% per year are achievable. And again, this is a close coupled system, so we would expect that similar or better results with a Cascade system as you would with a secondary type system. It also reduces your overall TWE, which is short for total equivalent warming impact, by impacting the direct portion of emissions rate used in the calculation, and anywhere from 50% or greater TWE reductions are achievable. You'll get comparable energy performance anywhere from plus or minus 3%. It is very dependent upon the baseline that you're comparing against, as well as the ambient conditions that your system would be operating in for a Cascade system. Next would be accelerated case temperature pull downs, anywhere from 66 to 75% improvement over traditional times for pulling cases down to temperature after defrost. What we have seen time and time again with CO2 is that cases and cases specifically can pull down to temperature in the matter of 15 minutes after defrost versus the 30 to 45 minutes that it takes today after a defrost cycle. So that means less shock on your product and improved case temperatures or longer time spans with cases being at temperature than what you would have traditionally with a standard DX system. So with that, Keely, I will turn it over to you.
Okay, thanks so much, Travis. I appreciate it. Our next presenter is Scott Martin. You should have control of the screen now if you can just advance one. Okay, Scott is going to talk to us about CO2 secondary coolant systems. Go ahead, Scott.
Hear me now?
I can, yes.
Sorry about that. I thought I had pressed it once. So what about CO2 as a secondary coolant, which creates the need to explain a little bit about primary and secondary. And refrigerant, remember, the fluid used to transfer heat from one source to another. Primary refrigerant is the refrigerants that we all use to today in DX systems like 404, 507, and R22. A sec coolant is used as fluid to transfer heat from, like a refrigerated space, a display case, back to the primary refrigerant. Secondary coolant systems are commonplace on medium temp side using single phase fluid. And there's two different types of secondary coolant there, single and two phase, where the glycol or brine is a type of single phase secondary coolant that only exchanges heat by sensible heat transfer. They have using CO2, the secondary coolant is now you have the latent heat absorption available because it's two-phase secondary coolant, meaning that it's boiling in the heat exchanger. It's really an evaporator now. So we'll hear through how types of systems work. We've got a concept piping diagram here of a system, and this box in the middle here is our what we call the condenser evaporator, and that is tied to your conventional refrigeration system. So on the side of the system, you tie that to your standard rack, and you can use any type of primary refrigerant that you choose on that side. The other side, the blue side, is the CO2 side of the condenser evaporator, and this is where we're condensing the CO2 into a liquid and pumping that liquid out into the store. So the primary job here is to condense the CO2 into a liquid. In the center there is a liquid vapor separator. It separates the vapor phase from the liquid. It drops to the bottom of the tank, is pumped back out into the store. The vapor separates to the top and goes up to our condenser evaporator where it's recondensed into a liquid. Circulating pump and I've got a picture of this, what this actually looks like. Its job is just to deliver the CO2 out to the display cases. It is a multi-stage centrifugal pump. It uses far less energy than traditional secondary coolants like propylene glycol. The evaporators are flooded design, so they're designed to be fully flooded with liquid CO2, so we get effectively 100% utilization of the heat transfer surface. They are designed differently than traditional DX evaporators or even DX CO2 evaporators. So it's important to have a evaporator in the display case or the walk-in freezer or walk-in cooler that's designed for flooded operation. The way to control the temperature is with a solenoid valve that's mounted right before the display case or walk-in freezer, and opening and closing that solenoid valve to let cold CO2 in the evaporator when the discharge air temp sensor in the display case or the freezer indicates there's a need for additional cooling. Here's a machine room of a real system with the condenser evaporators mounted above the liquid vapor separator. And those evaporators are piped into the standard refrigeration rack. Out of the Hermetic pump that's used to isolate the CO2. It's a very small pump. And of course, right there on the left is with insulated to show the frost there. Typical some of a few projects that we've done utilizing these technology. The one talk about the copper pipe going to the fixtures. That's an advantage of CO2 systems. You can use a lot smaller lines than traditional DX and especially traditional secondary systems. Then there's refrigerant charge in pounds. So a couple of stores in this same configuration measured against that DX, and you can see the savings in the right hand. Cost over 2,000 feet of copper, over 2,800 pounds of copper, since the copper is so much lighter, and a refrigerant charge savings in the final store there of 452 pounds. So that's greater than 50% savings in refrigerant charge. Then the store, same type of below there, 100 pounds of copper and feet, 1,200 pounds of copper, 400 pounds of refrigerant. So there's a pretty significant savings in the copper and the pound of refrigerant. And keep in mind that because this copper is smaller, it's easy for the contractor to install. Key discussed to talk about energy savings, and I think the best way to do that is to talk about what we really see in a store. And back in 2007, we put in a few of these stores, and Wayne will talk more about this in Food Lion. And Food Lion saw in their stores, comparable stores, a 2 to 3% energy savings over their conventional DX systems. And then here's a shot of some of the installations that we've had. The red dots there are what we've been talking about, using CO2 as a low temp secondary fluid. The blue dots are the DX Cascade installations, and the blue and purple combination there are using DX Cascade coupled with medium temp secondary CO2. So this eliminates all of the refrigerant out in the store. There's no glycol or no primary DX refrigerant. All of the store refrigeration is done by CO2, and temp is Cascade, and the medium temp is using CO2 as secondary fluid. So with that, I'm going to turn it back over to you.
Thanks very much, Scott. Next, what we're going to do is we're going to start to hear from our two of our supermarket partners, the first of whom is Wayne Rosa from Food Lion. He's going to talk about Food Lion's experience with both CO2 Cascade Systems and using CO2 as a secondary fluid in secondary loop systems. Go ahead, Wayne.
Can you hear me right, Keely?
I can, thanks.
All right. Keely mentioned today I'm going to talk about Food Lion's experience from the maintenance aspect of owning these refrigeration systems. And before I would like to begin, I want to explain the different type of advanced refrigeration systems we currently have ownership of, and we have 6. The store 2191 at the bottom of the page owned yesterday. So I have a lot of data experience on 2191 since it's just relatively open soon. So most of our experience that for slides is going to be about the other 5 stores. And Ernie started with a store in Dinwiddie, Virginia, where we did a medium temp glycol secondary loop, and our primary side was R507. We followed, I believe, the year after with another store in Montpelier where we tested the low temp CO2 secondary system. Again, primary system was 507. Later that year, we combined both of those technologies in a store in Portsmouth, Virginia, 2659, where we combined that technology, both a glycol medium temp system and a secondary CO2 system, low temp system. In 2009, we opened up our first CO2 Cascade system, where we had CO2 providing refrigeration to both the medium and low temp systems by utilizing a primary refrigerant of 507. That same year, we opened up a secondary Cascade system with our primary side being R407A. Again, 2191 that opened up yesterday, the primary side is R407A. A little bit about our refrigeration reductions, but before we can talk about it, I wanted everybody to understand what the actual capacities of our racks on site were for each one of these stores. So to the left of this column, you can see the primary refrigerant that we have, as well as the secondary fluid, and then the poundage for each one of those. We do not track our glycol capacity, so that's why the question marks in those 2 store columns there. But as you can see, the primary refrigerant is relatively low, even as the secondary is relatively low, except for the 2 Cascade systems, which, when you consider that the CO2 is used in both the medium temp and low temp cases throughout the store, it's relatively small charge. So what I've done in this slide here, again, we're showing our primary refrigerants in that first column beside the store numbers, what the advanced refrigeration system total charge is at that store. The DX system column is what our what our corporate average capacity charge is for those specific prototypes. When I'm matching up the 500 versus the 1,150 pounds of 5.7, we're carrying exact alike prototypes, and we're very prototypical specific chain. So with the exception of 1 or 2 cases, we take this floor plan over and over again. Right-hand column, you can see for store 2118, we reduced our primary refrigerant charge by 650 pounds, which is about 57%. And as you follow all the way through, you can see that pretty much every single advanced refrigeration technology we use, we had at least a 40% reduction in our primary refrigerant. I would point out the difference between the 2 Cascade systems, 2161 and 2157. The reason there's a different price charge for the advanced refrigeration system is in 2061, on our reclaim heat system for both HVAC and water, we chose to keep that traditional on the price side refrigerant. Whereas 2157, we did a glycol loop to provide that reclaim heat. So that enabled us to reduce the charge by another approximately 900 pounds. So we a little varied test on both of those Cascade technologies. So that's why the difference in refrigerant reductions from 1,300 pounds and 2,200 pounds, respectively 42% and 71%. Okay. On the next slide, I wanted to show a little bit about what our refrigerant savings are. So what I've done is taken those pounds of refrigerant that we offset with this advanced refrigeration system and tied dollar amount to it. So I used where average refrigerant costs were for both R407 and R407. So I think you'll see that not only was, I'm going to back up one slide. As you can see, we were slightly higher in our reduction of refrigerants from the earlier presentation. I did want to put an actual dollar savings that we saw in these stores. Our average cost for CO2 is less than $1. I'd like to talk a little bit about the leak rates that we're seeing with this technology. First, on the primary side, because the way systems are built, the primary refrigerant is, in some cases, relegated to only inside the mechanical house, with the exception of refrigeration lines running to the condenser. So because of the closed couple loop, and we can really keep an eye on the refrigerant use and monitor the refrigerant in those stores, in the rooms, we're only realizing about a 4% leak rate in these stores on the primary side. Several systems are averaging a 0% leak rate. And I'm not a big fan of percentages, so just to understand what 4% means in these 5 systems, rolling 1 year, they added 60 pounds of R507 to all 5 of these sites. That's a total for all the 5 sites. So I think the percentage at 4% really doesn't give clarity to how much we've been able to save on these stores. The CO2 leak rate, I'm putting 0% through 2009. I do have a little bit of a disclaimer on here in that we have decided in 2010 as an organization that we will track CO2 like we do any other refrigerant within our organization. So our full year 2009 records for CO2 use is not as concise as I would like it to be. Through 2010, we used 9,000 pounds of CO2. But on this is that it's not in a traditional leak sense that we've seen it with components or bad brazed joints or failure of any type. The system's operated as predicted. That we've had 2 major CO2 losses, both outside of our control. One was a power failure at the store, or generator backup, and the generator did not activate. So because of the warming of the CO2 and the expansion, the pressure relief valves worked as indicated and released the pressure and released it to the atmosphere. With another store, we had a water-cooled condenser in one of our southern regions. Unprecedented cold weather froze the plumbing lines. We didn't take the correct precautions to heat those lines, and because of high head pressures, because of the high cycle not working properly, we lost a charge there. Without those 2 losses, we are still seeing a 0%, what I would consider a traditional leak rate. One of the times we are seeing is that on some of the components, specifically in the pressure valve, we've seen 1 or 2 failures from the manufacturer of the pressure relief valve, so we've had to replace that valve. And in that term, I guess it would be a leak, but because of the dynamics of CO2 itself, it doesn't release itself all at one time, so we're able to capture those fairly quickly, but I want to have a call out on our leak rates. For refrigeration costs, we have all refrigeration costs for each one of our stores, and what we've done is I did a quick comparison for year-to-date to 2010 of what our refrigeration costs are for the CO2 systems and the glycol system versus what we're seeing in our standard stores, and we're adding about 49% less in refrigeration costs for the CO2 advanced systems than what we're seeing through our chain. And refrigeration costs, the way onto our refrigeration costs, we include all costs of refrigerant, and that includes the cost of CO2, all our refrigeration costs for parts, and all refrigeration costs for labor. And when we do parts and labor, it's dependent of whether it's an in-house technician or a backup contractor or service contractor that does the work for us. It all gets charged out to that refrigeration at that store, including all those costs in our refrigeration costs. Some of what we consider a successful implementation for Food Line has been training. I think training is one of the most important things when you're trying to use a CO2 system. The manufacturers that we have used have sponsored training at their factory, where we went through a 2-day intensive training program with our in-house technician group, installing contractors, and some ancillary technicians within our organization. What we liked about the factory-sponsored training was after you finish going through these training classes and seeing the pictures and the components that were needed, we're able to go out on site to the manufacturing floor as the racks themselves were being manufactured, and we're able to put hands-on training at the same time. We also followed up that training with on-site training at the job site, so that the technicians and the service contractors and the install contractors, we all work together to understand the challenges that each group was going to have, from an installation challenge to a maintenance challenge, so that if any issues arose, we can work through those issues together. We made sure to include our installing contractor, our house refrigeration technicians, any service or backup contractors. In our installations, we were able to have our installing contractors also be local contractors, so they were providing service. So the training was in of itself inclusive with the installing contractor. We also have what we call energy specialists that do all the refrigeration commissioning throughout our organization. So it's important for a group of specialists to be involved in all the training, as they will be doing the final commissioning of the system from a refrigerating functionality perspective, as well as to make sure that we're capturing all the energy savings that we can, as Scott mentioned earlier, to 2 to 3% energy reduction. And with all of our installations to date, we have mandated a factory startup. Again, I think that's part of the training, that in case of a major power outage, technician or backup contractor is going to have to start up this system more than one time, and we need the experience on hand to understand and go through the factory startup. Quick slide here to talk a little bit about installation. I think Scott mentioned earlier about the cost. For one, and every one of these installations, we considered it to be a cost-neutral installation. We work very closely with the manufacturers of the technology as well as the installing contractors. There were some call-outs for us that we did have a few added costs associated with these programs, but that was more of a timing issue than it was the technology, meaning that we had already had the stores approved, engineered, and out for bid/construction at the time we chose to implement this technology. So we did put a little bit of an added cost for the electric defrost, not from the manufacturer, but from the electrician wiring the electric defrost. Our standard criteria is to be hot gas defrost, so this was an add for the electrician. A mistake here on the slide, not the electronic expansion valves. I meant to put the solenoid valves here. There was an added cost from an electrician for wiring the solenoid valves. There was a added cost for the generator and condensing unit that we require on our stores. We've made one of our policies to have full backup generation at our stores at all of our CO2 stores, mainly for peak shaving generation, but as a backup to maintain the CO2 system integrity. When you take that system out, because we do it for energy savings, again, we consider it cost neutral for the installation. We felt like if we would have had the solenoid valves and electric defrost called out earlier in the engineering process and had that part of the bid package, we would have seen no additional charges through the bid process. Doing a few challenges that we've had with the CO2, mainly CO2 availability. It's not something that your traditional refrigeration supply houses keep an abundant stock of. So there's long lead times when ordering the quantities that we need for our stores. I believe if you look at the first slide, we go to the first slide, some of the CO2 use was anywhere from 900 to 2,000 pounds. It's not something that the supply houses keep in stock, so you have to worry about long lead times. As an organization, we've decided to keep a whole rack supply at our stores to make sure that if we have a refrigeration go down in the middle of the night and we do have an accidental release, that we can save our product by getting the rack back up and running as soon as possible. In one situation, we were lucky enough to have as our tenant there on site Refrigeration Supply House, and we did build a relationship with that supply house, and they're actually maintaining our CO2 supply for us. So when at all possible, build relationships with your local supply houses, and they will manage the CO2 availability for you. Travis had already mentioned one of the items that for your service technicians is to make sure they have the proper service tools, leak detectors, the heavy-duty hoses for charging the system, adapters and filters for the CO2 systems for charging the system. It's not a large cost, but it is a cost that you would incur owning these systems. And with that, I am finished with my presentation, Keely.
Okay, great. Thanks a lot, Wayne. A lot of very valuable information there. I'm going to hand over to Mark Henkel from Price Chopper. I'm just going to talk about Price Chopper's experience with their CO2 Cascade system in their Saratoga store in New York. So go ahead, Mark.
Thanks, Kaylee. I guess a lot of what I'm going to say is a repeat of what Wayne had said. To date, we haven't had any leaks on the primary side of our Cascade system. Reduced our refrigerant charge 50% at that store on that system.
Sorry, Mark, can you just briefly tell us how long the system has been in operation?
Yeah, Saratoga's been running for a little over 2 years now. It started up in March of 2008. The store actually opened in June of 2008. Legacy system, same thing with, as Wayne was saying, we involved the contractor and our maintenance technicians right up front with the system on the install. In fact, our technician almost became part of the contractor's crew. He was there at the store almost every day. System, understanding what they do. We'll start up with them. As the contractor, based on their opinion, it wasn't any more difficult than a normal system, in their opinion, to start, which is a good feedback. Our technician is been at store. That's still his primary store. 2 years he's been there. He put that system up against any system having a chain. Early on the startup, we had some issues with relief valves, etc. have some thread fittings leaking and stuff. We got those taken care of. A couple blow-offs. We had the power go out, and our generator didn't start to run the condensing unit either. But now have a full generator at that site, so we don't even have to use that condensing unit to keep the CO2 pressures down when you for power. Relative, like maintenance-wise, I don't have any hard numbers to give anybody as far as dollars go, but the opinion of our maintenance supervisor and the refrigeration techs that it's definitely a reduction. Compare similar stores that we put in there. About it. I mean, it's a lot of echoing of what Wayne had to say.
Okay. Well, thanks. I guess, but the first thing to do is to open the field up for questions. Just to repeat, to ask a question or indicate to me that you'd like to ask a question, there's a little hand button down in the right-hand corner of your screen. And because there are so many people on the line, what I'll do is I'll just call on people individually. Now, what you do have to do, of course, when I call on you, you're going to have to unmute your phone. So to do that, you have to press star 6. Let me start here with Stephen Mitchell. I see that you have a question. Go ahead. Steve, you have a question? Can you star 6? I think you're muted. Yeah, there we go.
Okay, great. This is a message. This is a question for Mark and Wayne. This is Steve Mitchell with King Cullen. Moving forward, when you guys make that the standard for low temperature, is CO2, or are you still in experimental mode?
Wayne or Mark?
Yeah, I'll take that one first. Right now, we're still in experimental mode. Our CO2 store opened in late 2006, early 2007. So only had about 3 years worth of experience with it. So we would consider it still an evolving technology. And that was our first secondary loop low temp, and we're now on the Cascade. So I think you got to wait it a little bit like any electronic device there. The technology is advancing so fast that there's new items that come out every day. So I'd say we're still experimental. We still want to make sure that when we need to make the corporate decision, we feel comfortable with the data that we've gathered, but we're not at the place where we're ready to make the commitment to CO2 in all new stores going forward.
And just Mark, I would say it's similar with us. The Cascade system we did up in Saratoga is still, obviously, we're still evaluating. We'd like to do another system for further evaluation, but as far as adopting it as a standard, we're not there yet.
Okay, thank you very much. Thanks, Mark. Thanks, Wayne. I appreciate that.
Great. Okay, good question. I see next, I'm just going to kind of go up the list here. So I see next Mike McFadden. Question? Mike, I think you probably have to press star 6.
Did that work?
Yeah, I hear you now.
Okay, I actually have a couple of questions. The first would be for Wayne, regarding whether he has any feel for which is better, the Cascade EX or the pump recirculating secondary on the glycol, since looks like he's tried both of them.
It depends on from which avenue you want to look at that. I think from a technician perspective, They like the glycol just because of the loop. The primary side is refrigeration, and they're very comfortable with the primary side and all these technologies. But when you start looking at the different pressure ratings for the different type technologies, glycol seems to be a little bit more appealing from a tech perspective. That is afraid, quote unquote, of that technology. I think second would be the CO2 secondary. It's not quite as complex when you're actually looking at the racks. There is a little bit of hesitance from the tech perspective on the Cascade side, because if you look at those racks and you look at the controls and you look at the set points, if you really look at it, the first time you look at it, it becomes a little bit overwhelming. But as the techs get more familiar with it and they understand it's just a refrigeration system, if they get out of their mind that it's CO2 and not a traditional refrigerant, they seem to get very comfortable with it very, very quickly.
So, yeah, I think just the difference between DX and flooded recirc, done with ammonia over the years, it's up and personal preferences.
Correct.
Okay, that was all I had.
Okay, thanks, Mike. I have a Lee M. You have a question? Lee, I think you have to press *6.
Hello.
Yeah,
yes.
I have it. Okay.
Yeah, okay. I pressed it. I guess it didn't take. So a question for Wayne. Thanks, and good numbers, good results on refrigerant reduction. A question on the total system cost. You mentioned it was a neutral installation. What was the total system kind of purchase price plus installation? Some of the add-ons. If there was a premium, was it? And how did you, or are you evaluating life cycle cost? The point will it kind of break even through the lower operating costs?
Last one first. The small premium we paid, when you add refrigeration and when you add some of the energy savings in there, we would prefer everything to be below a 2-year payback, and we're not going to see that 2-year payback. It's pushed out between the 5, 10, and possibly 15-year range, and it's really dependent on the price of the refrigerant and what you're seeing from an energy savings perspective. So that target kind of moves up and down the scale. The higher utility areas, we're going to see a quicker payback. Those that we're traditionally in low utility rates, it extends it. So when you look at that life cycle cost and where the payback is, if we ever decide to commit to it, that would be part of our decision making in how quick can we get that payback. I don't feel comfortable talking about the total cost of the system. I can share with you that we work very close with our manufacturing partners, both Hill Phoenix and Kaiser Warren, in negotiating those rates based on volume and knowing that it was a test. A lot of what we do, we make sure to have an open door format with our manufacturers, and we try to feed them back all the information that they need to make the system better and making it better, making it more cost productive for all the retailers out there. So it would be more of a valued out there. I know I bounced around that. Did I kind of answer what you were looking for?
Yeah, I think so. I think in terms of normally you all aim for a short payback, and in this case it could be between 5 and 15 years based on utility rates being high or low in certain markets.
Let me ask you though, is that now universally true for Cascade and secondary loop systems using CO2 as a secondary fluid, or is there a difference between those two?
For price range,
in terms of payback period.
Well, because our 2 Cascade systems are relatively new for us, we've only had them online. I think both of them under a year. Our energy numbers, we're not finished with our energy numbers, so I don't feel comfortable answering that. Our gut feeling is because one of the CO2 systems went into our LEED Silver certified store in Columbia, South Carolina. So we're monitoring that from a lead aspect and showing that it is a reduction in energy usage. I'm not comfortable without going through a full summer season to understand a full year's worth of energy to see exactly what that reduction is. So we'll go back and look at the total cost back per se on that technology.
I do want to mention to everybody that Greenchill is currently in the process of developing a report on a life cycle cost analysis of various types of advanced refrigeration technologies versus comparable centralized DX systems. There we're looking at CO2 Cascade Systems, we're looking at compact chiller systems, secondary loop systems using CO2 and using glycol, distributed systems. So everything that Greenchill considers an advanced refrigeration technology, we're gathering data from partners, and we're going to come out with a report that goes through and analyzes the life cycle costs of those systems versus centralized DX. I think that's going to be very, very useful for the industry. We're taking our time with it. The data gathering is a pretty intense and time-consuming process. I'm hoping to be able to have results by the end of this year. I'm certainly not going to promise that, but we are already getting quite a lot of press about the fact that we're even doing it. So I think you'll out as soon as we do have some kind of results for everybody. So I do want to mention that. Just ask the people who had raised their hands and have already asked their questions, if you could just click on your button again to put your hand down. That way I know whether you have another question or not. How do I go to Frank Davis? You have a question? I think you probably have to hit *6. Yeah, I can hear you now.
Okay. It does take on the first one, so a little bit of defense for the guys that you're telling everybody to press *6. For Wayne, when you experienced your loss during your power outage, how long was the power outage, and what percentage of loss of your charge did you experience? And then second question, compressor availability on the CO2 side.
I'm mistaken. The loss was earlier this year for the power outage. I want it was an extended over 6+ hours. One of the great things that we found out during that outage is we did have a full full-size generator to provide backup power there. That was first attempt at biodiesel there, so there was a little bit of a hiccup there with the generator there, but we've just resolved it. It maintained temperature without losing any CO2 for over 6 hours. The product in the cases, for lack of a better word, actually acted like a heat sink, and what we thought we were going to see more of a quick release of the CO2 within an hour to an hour and a half, remained much longer than what we thought. So we're happy in that situation. Although we ended up losing the CO2 charge, it was a nice lesson to learn that it's not as critical from a timing standpoint as we once thought. Second part of the question about the compressor availability, we have worked with our compressor suppliers to either provide us a spare compressor on site or have one locally available to us in case we do lose a compressor. I think Scott or Travis had mentioned earlier that in the infancy of CO2, most of these components were readily available in Europe, but not here in the U.S. So long lead times were not acceptable. So we're able to work with our compressor manufacturers and rack manufacturers to help support us in that need. To date, I don't believe we replaced one compressor, and we've got, like I said, I think our first CO2 CO2 system is approaching 3 years now.
Okay,
Wayne,
great.
I appreciate the answers, and also want to thank everybody else for a great presentation today. That's it for us.
Oh.
Thank you.
Thanks, Frank. Okay. And maybe I can ask Mark, too. I think, Mark, you mentioned that Price Chopper also had a power failure. How long did that last?
It was overnight. Probably 6 hours, 6 to 8 hours. The biggest thing, that we learned from it is that like one said, it doesn't instantly. You have it reduces the pressure, and then it takes a while for it to release again. So the same thing with Wayne. We keep a full charge at the store system as well.
Oh, great. I'm gonna mute everybody again, just because somebody's got me when they muted the phone. They didn't mute themselves back, which fine. I think we're muted again. But of course, the people answering the questions now, you're gonna have to press. No, I'm getting it. I'm not sure how that's working, but anyway, okay. So, John Baer, did I already have your question answered already, or John? Can I just ask, since it's not working here,
Hello?
Literally, can whoever has the dog in the background, can you mute your phone for us?
Can you hear me?
Can, thank you.
Okay, this is John. I have a question. I had two. One was, do we now have UL approval on the compressors for the CO2 Cascade?
I guess,
who would like to answer that? Maybe Travis.
Anybody.
Scott.
Because I was muting everybody again. Travis and Scott and Wayne and Mark, you're going to have to unmute yourself again.
Okay, hear me?
Yes, I can.
Yeah, we do have UL approval on the compressors, and the two compressor manufacturers that have UL, CO2 compressors available, both have UL, and UL is now available on the systems as well.
Good.
Cascade Systems, I might point out, is the next generation CO2 technology of transcritical. There is no UL standard or classification, if you will, for critical systems.
Right, much higher pressures. The second question I had was, I didn't hear anyone mention any issues at all with oil management on the CO2 DX side with the Cascade system. CO2, the low side of that Cascade system. Any problems with oil management?
This is Mark. We haven't had any issues with the oil. The only one thing that we came up with initially, and our tech could come up with, is a way to add the oil to the system with the higher pressures. As far as any oil returns or any of that, we haven't had any problems.
And I would agree with that. We have not seen any oil issues at all in our CO2 stores.
Oh, thank you, guys.
Thanks for the question. Appreciate it. Craig Rummer has his hand up. Craig, you question? Finding out that the first time that you press star 6, it's not working. So just keep pressing it and talking until we hear you. Yes.
Okay.
Hear you now.
All right. From a installer standpoint, because higher pressures, are the installers seeing ASME type brazier certifications and copper pipe quarantine requirements, those sort of things?
I'm sure who the best person is to answer that. Dean or Mark, I guess. Any input on that? You know, Travis and Scott, in your, I know that you guys do a lot of installer training with these newer types of systems, so maybe you can answer that too.
There's a special certification for CO2, and I think that's something that's important to note, that when I said earlier that you've got to do a good job of install leak testing and evacuation just like you do an HFC system. So there's no difference really in the process.
That's nice, because when you write the spec, then you don't have to demand that ASME certifications are passed by the brazers, and then the material handling is no more expensive because you don't have to quarantine the pipe or anything like that.
Okay, great. I do want to, since we're talking about leak tightness at installation, I do want to plug our Green Best Practices guidelines on installation leak tightness. We've got testing methodologies, testing standards, checklists. I think a good guideline for installation leak tightness. Actually, we are hearing from many supermarket companies that they just took the guidelines and they have incorporated them into their specs and just made that mandatory for the installation process. So check those out. It's on the Green Show website under reports and guidelines. Okay, next I've got Carlos Prieto. Question? I think, yes, I can.
There you go. All right, we came a little bit late because I had an issue in the email, but quick question on, for the loss of power, having the relief valves, is there a possibility of putting a recovery system or tank or something as opposed to just having the relief valves? At the beginning of the meeting, that's why I'm asking.
And that Wayne was talking about earlier, you can have a single condensing unit that's tied to a generator, a small generator, as opposed to a whole store generator that's big enough to power the entire refrigeration system. You can have a small 15, 20 kilowatt generator on a small condensing unit. It'll keep that CO2 vessel cold, and you won't lose any of the CO2 charge during a power failure.
Okay, but in the instance that you don't have a generator or the generator fails for whatever happened, I think at that other store, and they have an issue with generator not starting or something?
Yep.
Instead of having just relief valves, is there a possibility of having like a recovery tank or something else instead, or?
I think the expense of going, sure, anything is possible to answer your question and to have a way to recover, but they're going to have a pressure vessel that'll hold, extremely pressures like the two cylinders themselves. And the expense of that...
Well, weigh everything else?
Yeah.
Okay.
And the it's well because you're now capturing vapor versus the liquid.
Certainly. Oh, that's all.
Well, thanks for the question. I'm sorry, I can't remember actually if I already called on Craig Rummer or not. Your hand is still up, so there we go. Okay, so so I don't see any more questions here. We do have 8 more minutes till 3:30, so I think our speakers have definitely proven that they're very, very knowledgeable about this subject. So, and you've got them all here together, especially since these are the, as far as I know, are these the only 3 CO2 Cascade systems in the U.S. between Price Chopper and the 2 Food Lions? Case?
Can you hear me? Okay, there's There's one installed and running, but the store is not operated, and that's on the West Coast.
Okay.
With
all right. Good. Got the expertise of 3 of the 4 existing CO2 Cascade systems in the nation. So if you have questions about how this all works, it's a pretty good opportunity to ask them. And certainly Food Lion pioneered, and I know did a lot of measuring and data gathering on the CO2 use as a secondary fluid, and they've probably got one of the stores that's been in operation the longest using CO2 as a secondary fluid, so a great opportunity.
It's got a put Mark on the spot here too. Mark, your slide's only for Saratoga, but you also have a secondary installation, secondary CO2 installation. So Mark has both a cascade and a secondary loop, and I didn't know if you wanted to talk about the differences there.
Well, the secondary system that we did at Colony, that store there has a modular design on that low temp, and our refrigerant charge there was only 180 pounds, the whole low temp system on the primary side, versus a typical store that we'd have about 1,400 pounds. We haven't lost any refrigerant on that store, and that one's been open just over a year now, either primary or secondary.
And I have, of course, add that the Shopper Colony store is one of only 2 Green Shell Platinum certified stores in the entire nation. There are only 2, and the Colony store is one of them. And they also last year won Green Shell's award for, we call it the best of the best, for the best store in the nation. I of course don't want to badger people, and you know, to ask questions. We do have 5 more minutes. There you go. Okay, Arthur from CTA. Hit *6 again. Bob. Okay, good.
Okay. First, this could be either for Travis or Scott. Scott had mentioned about next generation CO2 transcritical. There have been discussions about using a Cascade medium temp CO2 system. Would there be advantages of using that if and when the compressors become available in the U.S.? The advantage of doing that rather than a secondary CO2 setup.
There's challenges. I'll go first, Travis. With critical systems, the pressures, like John Baird mentioned earlier, are a lot higher. You're talking about 1,400 pounds of discharge pressure. The advantages would be, though, that you have a total natural system. There's no ACs or HFOs in the future. No chemical refrigerants are required for the system, so that would be an edge. And as long as you can stay in cool climates like Mars is located in, and you stay in the subcritical region majority of the year, there's energy saving possibilities. The edge to that type of system would be there's a lot of heat available for heat reclaim. So if you have a use for that heat, there.
and I may have worded my question a little bit, and I was thinking of keeping the medium temp subcritical in a cascade setup is doing a cascaded medium temp CO2 X versus a secondary CO2 medium temp system.
Comment on that one, Scott. Rob, the temperatures that you condense the CO2 at in order to keep the pressures within a reasonable rating for use of copper in the system versus going to a stainless steel or black iron pipe. You're going to be condensing in the 22 or 20 to 28 degree range. Condensing your CO2 at those temperatures would really make sense to have a compressor system to drive your medium temp, since the temperature for the CO2 is at an ideal condition or temperature for using the medium temps, similar to what you have on glycol today with 22 to 25 degree glycol. So you wouldn't really have that.
Did that answer your question? Oh, great. I think we'll have one final one. I have a question from David Callender. You've got the floor, the final question. You press R6 again. David? Yes. Yes. Go ahead. Go ahead with your question.
Hello?
Yeah, David. Yes, go ahead.
Okay.
Ask your question.
I'm sorry. I just wanted to know if anyone has looked, are all these systems we're talking about today in new installs, or are any of these been in a retrofit application for an existing store?
All lines, adventures into CO2 have been all in new store installations.
Okay.
Same Rice Shopper, they're all new systems.
Right. So
Mark,
really,
your Saratoga store, it was a new system, but it was as part of a store expansion, as part of a whole remodel process, right?
Right. It was an expansion remodel, and that system was new to the store.
And you were kind of able to, though, hook the CO2 Cascade system into the existing system, the original store, though, right? Weren't you?
No, it's a separate system on its own. It's
okay.
Right into the whole expansion side of that store.
Okay. Right. Okay. Then I think we certainly we certainly had a lot of really, really good questions. I appreciate it from everybody, that you're engaged in the topic, and that we were to have share some information and have a good discussion. So thank you very much to our speakers. Thanks to Mark and Wayne and Travis and Scott. Our ability to hold these webinars on a monthly basis depends on usually our partners volunteering to be speakers. So if it weren't for them, we wouldn't have a Green Show webinar series. Thanks everyone for attending. If you all have, or if anyone has any follow-up questions, feel free to contact me. And as I said, it won't be immediately, but eventually this webinar will be posted on the Green Show website. So great. So have a great rest of the day. And again, thanks for attending. What I should probably do is make a plug for the next webinar in the series. It is, let me just check here. It's a webinar on ammonia. I believe it is on, yes, it's a Green Show webinar, Ammonia Systems for Supermarkets. It's on August the 19th at 2 o'clock. And like I said, if you would like to be added to our webinar invitation list, please just send me an email. We're very, very happy to do that. So thanks, everybody, and have a great rest of the day. Bye.
Bye-bye.